Hi, I'm Dr. Neeland, and I'm going to be telling you about a machine, an instrument here that takes solvents off of, let's say, a reaction that you want to work up. It's called a roto-evaporator. We don't like to use the name roto-evaporator. We oftentimes just say rotovap. And the idea behind this is that you take a sealed system, you put on a flask that you want to eliminate the solvent from, and you put it under vacuum. And if you go to physical chemistry, when you put things under a vacuum, you get a reduced boiling point because there's less atmospheric pressure on it. And so this goes much more quickly when you put it under vacuum. Your boiling point of water, for instance, might go down to as low as 80 degrees or maybe even lower, depending on the vacuum that you put on this machine. And if something's at 80 degrees, it's going to boil a lot quicker than, let's say, when it's at the 100 degrees Celsius at normal pressure. Now, I'm going to tell you a story. Back in the early days of Mount Everest, a lot of British explorers would go up Mount Everest and they wanted to conquer the mountain because it was there. Sir Edmund Hillary, right? And you know, 3/4 of the way up, they would say, you know what, it's time for a spot of tea. And so they'd be way up on the Mount Everest, 3/4 of the way up, which is a very high mountain. And they would stop to make some tea. So they would melt some snow, and they wouldn't have a beaker with a Bunsen burner, but they would have a pot where they had melted the snow. And they would make themselves a spot of tea. And they would pour the nice boiling water. You can see the water's boiling, it's bubbling. And they would make their tea. And then they would raise up their tea. And with their pinky finger appropriately extended, they would take a sip of their tea 3/4 of the way up Mount Everest. And they would go, oh, that's tepid. This isn't hot tea. This is only warm tea. And so they would talk to the guy who had boiled the water and say, how come you didn't boil the water? And he'd say, I did boil the water. But what they forgot was that when you go up Mount Everest, there's less atmosphere on you. There are less air molecules on you. There's less pressure on you. So the water, even though it looks like it's boiling, and it is boiling, it's boiling at a much lower temperature. And so therefore they wouldn't get a hot cup of tea out of this. They would get a tepid cup of tea. This is what a rotovap does. It takes a solvent, in this case water, puts it under a high vacuum, which kind of mimics what happens when you go up 3/4 of the way up Mount Everest. Suddenly the boiling point of your solvent water is no longer 100 degrees Celsius. It comes off at a lower temperature. And we do this in the lab all the time with the roto-evaporator. So you're walking up to a cold rotovap. Nobody's used it before you. The first thing you do is click on the power bar. This supplies power to the pump inside this bucket and also to the roto-evaporator. This bucket here has water in it that's going to be the cooling flow that goes through the condenser. And it's nice if it's actually cold water. So what you do is you add ice. So you've added ice to the bucket now, so you've got cold water going through these condensing coils. The next thing you need to do is put this under vacuum, because we want to be 3/4 of the way up Mount Everest. Before you turn on the vacuum pump, you have to take a look at the T-valves. Here are the two T-valves here. You have to make sure that they're closed. If they're in the open position and you turn the vacuum pump on, then you're just going to be sucking air through the system, which is kind of mean to the vacuum pump. So make sure that the two T-valves are perpendicular to the flow of the pipe here. Once you've got that done, then you go over to the vacuum pump and turn it on. Okay, so what you're looking at here is a vacuum pump. It's an oil-cooled vacuum pump. And there's a button, and when you turn it on, you'll hear the vacuum pump turn on. And it's now evacuating the system. You'll notice this tube here. This is a vacuum tube. It goes all the way down and leads over to the roto-evaporators. Okay, so you've put ice in the bucket. You've got cold water going through the condensing coils. You've made sure that the T-valves are off or closed. You've turned on the vacuum pump. This is all evacuated now. So the next thing you want to do is walk up and turn on the roto-evaporator. There's an in-on button there, and there's an on button there. This is now open. This is the heater. This is the rotator part of the roto-evaporator. You're going to take your sample and you're going to put it on the end of this splash guard, And before you let go, you're going to make sure that this is tight and this is tight. See that? And you want to make sure they're tight, because otherwise when you open up the T-valve, all the air will get sucked into the vacuum pump, which is a waste. So while holding on to this flask, you put on a little safety clamp like this so it doesn't fall off. You now open up the T-valve, and if you listen carefully, you'll hear the system being evacuated. Now, since the system is being evacuated, you want to quickly get this rotating. And what this is going to do is basically increase the surface area of your solvent, because now there's a very thin layer of solvent that's on the inside of this flask as the flask rotates around and around. And that's from there, that's going to be the main evaporation point as the solvent vapors go up the roto-evaporator, hit the condensing coils, and then drip down into the reservoir. Now to speed this process up, of course, we have a nice little bucket of water here, which is warm water. You can control the temperature of this water that's inside this little pot here with this vial, and away we go. So drop it down, lock it. You'll notice that the reservoir is now in an ice water bath. Notice it's not just ice, but ice water. This is warm water that I'm putting my hand in. That's going to heat up the solvent. And now under vacuum, the vapors are going to come off quite rapidly, and then you'll slowly see them dripping off of that condensing coil and going down into that reservoir. Now you have to wait. And as you wait, you're going to see that as the solvent evaporates, what's dissolved in the solvent, which in this case are some white crystals of our product, are going to start to precipitate out. If you get bored, you can actually speed up the rate of spin, and that will speed up the rate of evaporation of the solvent. Okay, so now you can see that as we've lost a lot of our solvent, if you'll notice, I'll slow the spinning down. Do you see the crystals that are coming out of the solvent? That's our goal. So we want to take this right to dryness now. And what will happen is all the solvent has now gone up under vacuum, hit the condensing coils, dropped into the receiving flask or the reservoir, and it's left just our nice pure crystals behind with no solvent. Okay, so now take a look. The question always is, when do you know that this is done? It's very simple. When you can see no solvent sloshing around in your round bottom flask, it's all pure crystals, and you can see no drops coming off this condensing coil system, then all your solvent must have already gone over, and this must be now a dry flask. So that's how you know when to stop the roto-evaporator. So you now want to take off this flask, and you want to do it safely, and you want to do it properly so you don't lose all your product. So the very first thing you have to do is close off this T-valve so that this is no longer under vacuum. So turn it 90 degrees to the Tygon tubing, the black Tygon tubing. That shuts off the vacuum pump from further evacuating this system. Now this is still under vacuum, of course. It's just not under a continuous vacuum. So the next thing that you're going to do is raise this out of the water. So now your flask that was rotating, that had the solvent in it, is just hanging in the air, but it's held on by vacuum. And you're now going to release the vacuum inside the system, and because the T-valve is closed, the vacuum pump's not going to care. So if you listen, there was just a little, and that is now an evacuated system. There's no vacuum left in there, which means you can now pull this off. So again, take off your safety clip, and don't pull it down, but twist. Okay, so you had the flask on like this. You take off the blue safety clip, and now twist the flask. Hold the splash guard. That's the splash guard right here. Hold the splash guard, twist the round bottom flask, and then gently pull down. You never want to try this when you're under vacuum, because if you try this under vacuum, all the air will rush in and it'll send all your crystals shooting up through the splash guard and up through the rest of the machine. You don't want that to happen. So it's very important to evacuate, take the vacuum away by opening up that particular knob. So you've taken your flask off the roto-evaporator. All the solvent is gone. But is it all gone? It's not. There are little bits of vapor of the solvent still left inside this flask. You can't see it. If you wave the vapors towards your nose, oh yeah, you can smell it. Here's a little trick that I highly recommend. Take some Tygon tubing, put it on the end of the air spigot, not the gas spigot. The gas spigot is blue. The air spigot is orange, okay? So don't be blowing natural gas into here. That's not a good idea. Turn on the air, and if you have a Tygon tubing, you have good control now. Now all you have to do is kind of play rotovap. Now that's on a little bit too strongly, so I'm going to back off on its pressure. Yeah, that's about right. Now you can put your Tygon tubing with the air just barely coming out of the end of this. Put it inside the tube, play rotovap. Let the air go into the center of the flask. You're driving out the last little bit of solvent vapors when you do this. That way, when you take NMRs and IRs, there will be no solvent contamination in your spectra. And you don't have to do it long, maybe 30 seconds. And this will drive off the last little bit of solvent vapors so that your product will be nice and pure for spectroscopic analysis. So sometimes you don't have a solid crystal as your compound. Sometimes it's an oil. And when you're roto-evaporating an oil, you'll see that you'll get a sort of an oily band that starts to accumulate on the outside here, kind of like the equator on the Earth. And of course you'll know that it's done when you don't see any solvent coming off the coils anymore, or any solvent that's left in the round bottom flask. If you look very carefully, where my finger is pointing, there's an oily band. Where my finger is pointing right now, you'll see an oily band on the side of the round bottom flask. And of course, if you have solids, you know, if there are crystals, these would be crystals. But if it's an oil, it just looks like what I'm looking at right here. And that's how you can tell when it's done, because if the oily band is on the outside, that means there's no solvent molecules dissolving it to make it sit in the bottom. And so that's your clue that when your oil is done, when you're roto-evaporating an oil. And so the procedure when this is done will be exactly the same as for a crystal. What you're going to do is you're going to stop the roto-evaporator from spinning first. Then what you're going to do is close off the T-valve. Then you're going to release the vacuum. So there's no vacuum inside the roto-evaporator. The vacuum pump is still pumping, but of course the vacuum from the roto-evaporator can't get in because the T-valve is closed. You take off the blue safety clip. You twist and pull down. Notice no vacuum is holding it on. And then you take this flask, which now has a little bit of oil in the bottom of it, and you're going to go over to this Tygon tubing, and just as before, you're going to blow air into here very gently, play rotovap. You're going to rotate the flask in your hand while the Tygon tube with air is pushing air into this and driving off the last little bits of solvent vapor. Okay, so the procedure hasn't changed. For when you're done evaporating the solvent off the roto-evaporator, you always drive off the last little bit of solvent vapors with a bit of an airstream from Tygon tubing. So when you're wanting to evaporate solvent and you're using a round bottom flask, there's a general kind of a rule. If you fill up a flask any more than absolute maximum 2/3, that would be a mistake. This is the maximum fill rate that you want for any round bottom flask. So if you proportionally bump this up, and this is now a 250 ml round bottom flask, it's still roughly 2/3 full at a maximum. Myself, when I'm doing research, I personally like 50% because that stops any bumping that might occur. If you find yourself filling up a flask and it starts looking like this before you put it on the roto-evaporator, you are asking for trouble. This is definitely going to bump, and then you're going to end up with the wonderful task of having to clean the rotovap and the splash guard and starting all over again. So eliminate that. Don't do that. That is way too full to put on a roto-evaporator. 2/3 at the max. 50% is even better. Now you want to shut everything down because there may not be a person behind you waiting, and this may be off for like 12 hours. So you now need to return to the cold rotovap stage. The very first thing you have to do is shut off the vacuum pump. Now, once this vacuum pump is shut off, it's still under vacuum, and it may start drawing the oil out of the vacuum pump into the tubes. So the very next thing you have to do is walk quickly over to the T-valve and release the vacuum in the system. So if you listen, you'll hear that last little bit of the vacuum coming out. There it was. And now everything has no vacuum. It's back to atmospheric pressure. And now you can kind of just reverse all of the things that you did. You can shut off the 2 power buttons that are on the machine itself. You can go back to the power bar, because right now we still have cold water going through the condenser coils. And to shut those off is just hitting this power button, this red power button here. If you touch this bucket, you'll actually feel it vibrating. When you hit this power key, there's no vibration anymore on this bucket that I'm touching. And now you're back to a cold rotovap situation.